Sir, not audible, sir. You're in mute.
Okay. Yeah, so I welcome you all back to the second session on the second day. We have with us Dr. Lalitha Guruprasad, Professor. You can't hear me?
Now we can hear you. Yes. We can
you
hear
hear
you.
me?
Yes, yes.
Yes, sir.
Yeah, so Professor Lalitha Guruprasad is a professor of chemistry at University of Hyderabad. And she obtained a PhD from Usman University and has a vast postdoctoral experience at Birkbeck College, University of London, then at University of Cambridge. She came back in 1998 and was a postdoc at CCMB India, after which she joined University of Hyderabad. So she'll be talking to us today on problem identification, formulation of hypothesis. Over to you, ma'am.
Thank you, Professor Hassan. Good afternoon, one and all. I hope you had enough time to eat quick meal. So let's start with the presentation. This is a slide which I had shown you yesterday already. And in this slide, basically, what I'm showing you is the workflow for actually solving a research problem. And this is what we do day in and day out in the research labs. And I have actually highlighted point 1 and point 3 in bold. That is formulating the research problem and development of working hypotheses. These two will be actually discussed with me in the presentation today. Professor Hargopal will be telling you how to test the hypothesis. So testing the hypothesis part he will tell you, and I'll tell you how to develop the working hypothesis. So to start a research project, the researcher must first select a problem and a problem that one wants to study, and to decide the general area of interest, and that's a starting point. Like, I would say organic chemistry, and within organic chemistry, what is it that they want to study? The subject of their interest, which they would like to probe in further, should be decided. Like, say, for example, indole chemistry is one example I can think of within organic chemistry. And so here the organic chemistry becomes the general topic, but within that, the specific research problem would, as I said, would be the indole chemistry. So this is the first step of any scientific investigation. So basically, to formulate the research problem, the researcher, whoever is working, the supervisor, student, doesn't matter, they should understand the problem thoroughly, and then they should rephrase the same several times in order to get meaningful, in order to put in enough thought process while, framing the problem from all angles, and most importantly from the analytical point of view. And for this, I would say that access to libraries of huge importance. And the second aspect of a research problem is literature review. So though most books write formulating of research problem followed by literature review, it just doesn't happen like that. You have to do the literature review, and from literature review only you're able to formulate the problem. So though it is said written separately in most of the textbooks, I would say that literature review is inbuilt into the as the first step of any research problem. So in literature review, what does one do? One does a brief collection of all the research papers that are published, and one should make an extensive survey connected to the problem of your interest. That is, as I said, the indole chemistry. And often you should store these papers in your either as a print copy or as an e-copy, because you will be citing these papers later. And most often, because these are in PDF versions, there are many, the PDF, the software will allow you to highlight certain passages. It will allow you to make notes. Once you read a paper, just don't close it. You make notes, you highlight the important parts so that, when you actually come back to writing the manuscript, it will actually help you. And the third and most important part is the development of working hypothesis. And I will be talking to you about framing the research problem and the working hypothesis, how to frame the working hypothesis. So after the literature survey, the researcher should state clearly, in no mincing terms, what the working hypothesis is. So working hypothesis is basically a tentative assumption that one makes in order to draw out and test logical and empirical consequences. We have seen what is empirical, what is logical yesterday. Basically, the writing of a hypothesis, that actually sharpens one's thinking, and having a good hypothesis will allow the researcher to decide whether they are going in the right track or in the wrong track during the course of the work. And the next step would be to prepare or design the protocols. So what is preparing the research protocols? Once again, this is a stage where I decide and collect all the papers that talk about the, yesterday we were taking the example of CC bond forming reactions. I will take notes of all the CC bond forming reactions, and then I should choose such papers where I'm able to put minimal effort, less time, less money. I mean, the reagents also should be cheaper. And maybe, I should also choose to work towards green chemistry, where water is a solvent mainly. So I should try to put more emphasis on such papers. So collection of all the protocols that you will be doing in your work is the important step. So this also becomes a part of your research methodology. And once you have these things in place, your research will, hopefully sail smooth. And then determining the sample design. So which is the first experiment that one conducts, that will tell you whether you'll be excited or, you'll be demotivated in your science, science journey. So for example, supposing say my supervisor has told me to do 50 molecule synthesis is what I should be doing in my lab. So that is called as 50 enumerations with different substituents is what I should do. So instead of, so what I can do is I can take a sample which is as general as possible, because if I get a positive result in this sample, then I'll be able to generalize the results to all other samples of my study, right? So the choice of the molecule here is very important, because if you take a very trivial molecule, then yes, you will get a result, but then the subsequent molecule synthesis will not work. So a lot of time will be wasted. So therefore, to be able to choose the representative molecule out of from the ensemble of molecules, okay, that is called as the sample design, to find out which is the optimal molecule that you'd want to first work with. Then of course you have to collect the data. That is, after doing the experiments, then one should record the spectrum, as I said again, in NMR, IR, so on and so forth. One should be able to determine the melting points. So all these will become the collection of data. And then you have the analysis of data, whatever you have collected. If it's, depending on the subject, one should be able to interpret the data that was collected, that it's called as analysis of data. And as I said, for example, a lot of statistics, I was just talking to Professor Hassan, a lot of statistics is involved in this. But again, going back from chemistry, it's like interpreting the spectrum and trying to find out what is the structure of the likely molecule. Did I get my product or not? And then hypothesis testing. After analyzing the data with the help of various, these data analysis tools, I will go back and find out if my hypothesis that I have set out initially to start with is right or wrong. And then I will interpret the data, and then I will make certain I'll generalize the results that I've identified. I'll say whether the desired product is obtained, or if there are any side products that are obtained in the due course of my preparations, my synthesis. And of course, it has to culminate with the report writing, and that should ultimately go into a manuscript writing. So coming now to the research problem, which is one of the topics today. So what is a research problem? A research problem basically indicates that there are certain gaps in the knowledge that we have about a particular topic. So a research problem points to either a problematic observation, or you already have made an observation, but then there are certain puzzling consequences to the earlier proposed theory, or it's actually a totally new idea. Nobody has worked on it, so on and so forth. So all these will make the research problem. So research problem is the focus or the research, or it's the main reason why somebody is engaged in, in the field of research. And identification and formulation of a research problem, it's the starting point of any research activity. Once, actually, I feel that identifying the right problem or formulating the right problem is more difficult than actually solving it. I think there aren't many problems. There are perhaps many problems, but getting the right problem, which will allow you to work for the next 20 to 30 years for your entire career. I think that's quite hard and it's quite tricky. So yeah, and research problem, identifying the research problem is the first logical step. And yeah, at this stage, I would like to tell you 2 points. One is a synopsis. So the synopsis is actually a formalized version of a research problem. If you apply for a, I'd say at the end of 1 or 2 years of your PhD degree, of your PhD work, the university will ask you to submit a synopsis. Okay. So in the synopsis, every student who's working towards the PhD degree will submit synopsis after 1 or 2 years of their PhD work. So it's basically a statement of a well-formulated research problem. And so once you have your synopsis in hand, you exactly know how to proceed for the rest of your PhD journey. Likewise, when we submit projects to various funding agencies, also they ask us to submit a research proposal. So a research proposal is also a very carefully formulated, a research proposal will have many components, but the research problem is an integral part of a research proposal. So yeah, so one should know that synopsis submission and project proposal submission also are required. When you write those, you actually frame a research problem. So the most important part here is what is the source of your problem. And as per the existing practices, one can actually say that research supervisor is the best source for a research problem. It is well known that most of the PhD students who generally join a lab, within the first 1 month, they leave the job of finding the research problem to the supervisor. This is partly because they don't understand. They're fresh MSc students. They do not understand how to do things. So they ask the supervisor to suggest a problem, or perhaps they're a little lazy to strain their mind to find the research problem, or they actually totally depend on the supervisor for the problem. That's they have a blind faith in the supervisor. Let me put it that way. And what does supervisor in turn do? The supervisor will look at the existing literature to find the research problem. They will read from books, they will read from research journals. Many a times, whatever is you have done for your PhD and postdoc, one will try to extend that and formulate certain research problems. And often you get ideas by attending seminars. And often we end up reviewing papers for somebody else. And if there is a nice point in the paper, one can always pick up that, and without doing any, in no non-ethical means, one should be able to, frame a research problem. So that's one way. So, so the literature survey tells you that there is an unexplored area, and then one can formulate a hypothesis, and then one can form a research problem to go in that direction. And the third source, I would say, is most of the funding agencies declare certain priority research areas. For example, if CSR, DBT, DST, for all of them, not DBT, of course, for CSR and DST, they mainly talk about nanochemistry. Nanochemistry or nanomaterials is the thrust area. So based upon the thrust areas given by the funding agencies, also one can find out the important research problems. And right now, if you say DST, DBT, they're only looking at COVID research, COVID vaccine, COVID research, social science applications, and so on can be, the thrust areas in the current year. And there are certain government offices like DRDO, BARC, so on, and also industries. Okay, they have their own research mandate. The industry knows that it will only work on onco drugs, cancer drugs. Okay, so they'll not want to work on diabetes or hypertension drugs. So within their mandate, the researchers are supposed to work in these areas. And the ideas can, as I said, I'll just leave these. The ideas can come from daily problems. Because there is a change in technology, that a new research problem can be there. And as I said, one will have their own research interest, and therefore, uh, one will have a research problem. But if I say that if these four are the reasons for the choice of a problem, then the research activity will become more of a ritual. Okay, there is nothing exciting in them. I believe that one can produce quality research only when the problem is coming from within. Like the research problem should spring from within. Then I would think that the problem is quite a valid problem. Like, for example, there's a substantial difference in choosing a research problem. A supervisor can suggest you about 5 problems and say choose one among these 5. There's a huge difference between choosing one from the 5 of your supervisor's list than identifying one from your own intellectual thinking. This intellectual thinking is actually called as intellectual suffering. That is, you're subjecting your mind to a lot of thinking. It's called as burning midnight oil. There's an English idiom. So you have to think for yourself and come up with a problem. And intellectual suffering is the source of actually creative ideas, and it actually gives a lot of excitement to the research problems. And that's, I think, the best way of doing things. And sometimes I ask students, why do you want to work on cancer molecules? They say that their grandmother is suffering from cancer, or somebody passed away because of cancer or TB, and therefore they find that as a good reason to work on a particular area. So, I'll still say that the research problem should come from within, and one has to be creative in the research problem. Therefore, what we normally observe is that the Indian movies or cinemas are much more creative than the Indian science. That is because we do a lot of copy paste research from Western thoughts than thinking for ourselves. So again, the research problem should be a inner experience. Maybe the research scholar, the first 3 years, they may not have any idea. So it's fair enough to take from the supervisor. But the 3rd and 4th years, the research student should be able to think of their own, at least one part of the project of the research of the PhD thesis should be their own innovative idea. Then actually, they'll end up being better scientists in the future years. So there are certain criteria for a good research problem. Some of these will also come in the subsequent slides. The important aspect is it should be a sufficiently, it should be the novelty. Okay, the work should be sufficiently original, because there's a lot of issue about plagiarism, ethics in research, so on and so forth. So there should not be any objection in future because of any duplication. And the problem should be interesting to the investigator himself and to the student who's doing the work. And the problem should be of importance. That is, it should be worthwhile to work on the problem. And if the problem does not add to any knowledge, if it does not add to any current practices, if it does not improve the life of a person, then it's better not to do such science. Yesterday we were talking about Pasteur's quadrant. Okay, Donald Stokes. So recall the Pasteur's quadrant and decide in which of those quadrants, not in the 4th quadrant, in which of those other 3 quadrants your research lies. And of course, feasibility is basically the a feasibility of the problem. Okay, if you have very difficult problems in mind, if you want to explore, is there life on Mars? Okay, given our research conditions, given the accessibility to information or the equipment we have, these are very difficult problems to work on. Okay, so feasibility of the problem is very important. So don't take too difficult problems. Basically, you should have the availability of data that you want to work on, and then there should be cooperation within your institute with the supervisor from the neighboring labs, availability of guidance, availability of facilities, experience, creativity. I'll elaborate these again, but then these are all the important criteria for choosing a good research problem. Right. So, yeah. So how to formulate a research problem? So this again depends upon the topic of your study, what one would like to study, whether it's social sciences or natural sciences. Among natural sciences, once again, there are many branches. Like say, for example, chemistry. Chemistry itself has many fine walls, and then you can collaborate with quite a few people. The chemists can collaborate with physicists as well as with biologists. Okay, so all these things have to be kept in mind. At what do you want to work in pure science? Do you want to work in applied science? Do you want to work in multidisciplinary areas? So on and so forth. These are all the questions that one can ask for themselves before one is able to formulate a problem. So here, basically, the selection of an appropriate research problem uh, is coming because of the evaluation of alternatives to certain criteria. So, for example, as I said, your supervisor will tell you 5 topics is what perhaps the supervisor can give you, and then you should be able to choose one among those 5 because, yeah, for obvious reasons, you can't work simultaneously on too many problems. So each identified problem must be evaluated in terms of certain criteria, which is the internal criteria as well as the external criteria. So yeah, so what is the internal criteria to start with? First is the researcher's interest. This we have spoken briefly earlier. So yeah, the problem out of the 5, we have now chosen one. The problem should be of interest to the researcher, and it should be so interesting that it is able to throw a challenge to the person who's working on it. But I wouldn't say that the challenge should be too big a challenge. See, if the challenge is too big, then it's very hard to find a solution. The results will not come easily. That will actually lead into discouragement. The student will be discouraged. So you should work on challenging problems because you want to be excited about your research. If somebody asks you, you should not tell something very trivial. You should say that this is the frontier area that you're working on, but at the same time be moderate so that you will get reasonable results within a reasonable time, because these are all time bound projects, time bound problems, right? 3 years to 5 years you should be able to finish your PhD. So don't take very hard problems. And yeah, so take a problem which is interesting, which is challenging, because without interest or without curiosity, it's very difficult to sustain. Like you have to day in and day out, day after day for next 5 years you have to work on the problem. So you should have sustained perseverance and interest in the problem. So that sustenance, and many a times you will be demotivated and you have to motivate yourself. That's something very important in every, not only student, also in our lives. Even when we become teachers, when we don't see the result coming, it can be demotivating, but we have to encourage ourselves. Yeah. And yeah, and this research endeavor is also very time consuming. It requires a lot of hard work, and many a times you'll have certain unforeseen problems. Nobody has foreseen that COVID will come, we'll all be staying at home and giving these webinars, than seeing each of us face to face. So like all these unforeseen problems also must be kept in mind. And as I said, keep uh, keep motivating yourself such that your research keeps going. And often I see that the student is interested, but then they don't have the educational background. They don't have experience. They don't have. They're not sensitive to the problem. They don't have the outlook towards research. They've just joined because they feel that is one other area that they can explore. They didn't get a job, so they come for PhD. Many are keen to do, but some students also have this attitude. So this is the problems that students face. I feel that they don't have the sufficient background. So at this stage, I think talking to a guide will help you. Of course, we keep motivating students every day, but talking to a senior or guide is very important to keep your interest going. And then researchers' own resources are of many varieties. Availability of chemicals is one. If Sigma Aldrich is not able to supply chemicals on time, then our research is at stake. And the financial part is again very important. If there is no money, then we cannot do research. So so one should write for such problems which require huge funds. It's better to write to financial supporting agencies, funding agencies, by writing grants. And again, time is a very important resource. We may not realize this. The first 2 years is like a honeymoon period. Students are having good time, and then third year they feel that there is no result coming out. It's not like that. So time is a very important aspect, and therefore, write a research project, which can be done in 3 years to 5 years and not beyond that. And researchers' competence is also very important. And one must be competent to plan and carry out the. I can write very difficult problem, but I'm not equipped to work in that area. I don't have the intellectual capability. So the researcher's competence is very important, and the researcher should have adequate knowledge in the subject, in the methodologies, in the statistical procedures of analyzing the data. One should have adequate knowledge, and not just knowledge, expertise is what is actually required here. And many a times, courses like this, or PhD coursework that is given by your institutes is very important. And yeah, and sometimes what happens is that the research project is very important, exciting, but you don't have the entire competence. So then what one can do is they can write to they can collaborate with somebody. They can tell that, I know these things, but the other part is something that I don't know to do. Can we collaborate on this project? This is how, perhaps one can overcome their limitations and start a collaborative project. And external criteria is something that, which is not in our hands, but we should still take care of it, because it's our research problem. As I said, researchability on the problem. If the research problem is not feasible, as I said, if I want to work on a very broad area, first of all, you should not work on very comprehensive areas, because these are all time-bound projects. Okay, so the project should be feasible. As I said, I should not try to look for life on Mars. I should not work on very broad areas. Try to be as I wouldn't say, don't be too narrowed down once again. So you should have the overall understanding, at the same time work vertically down in one particular area. The problem has to be novel. Otherwise, if somebody else has already solved it, we are wasting that time and money. And importance and urgency of the problem. This is something very interesting, because when we review a paper for somebody else, for some journal, they ask, is this problem important now? Is this problem important for next 3 years? Will it be important for next 10 years? Even a journal will accept your paper only if you are working on important problems. If you say that, no, it's not important after 5 years, or it's not currently important, then the paper may not have, get the due, importance. So work only on important problems. And facilities, research facilities is something that is very important, because you want to work in a particular institute. But again, if you, it's also, it's okay to collaborate with somebody, because, you want to use their instrument. Okay? But then you should not end up doing your entire research problem in some other institute, because you don't have it. Maybe 80% of your work can be done in your institute, 20% can be done in a collaborative institute, but you can also overcome this by having collaborations. And usefulness and social relevance is something very important. Again, it's like importance and urgency. And ethical issues. Say, if you want to work on a certain research problem, it should not have any ethical problems. For example, okay. So these have to be understood. So many institutes have this, ethics committees are there in institutes, and a research problem should be shown to the ethics committee, and they should give ethical clearance. Only then, one should be able to work on problems. For example, I should not be working on using a chemical which is carcinogenic. Okay, as simple as that. Right, and industry should not be leaving its pollutants into a lake nearby. So such things have to be, taken care of. So, like for example, there are many people who work on clinical trials. Okay, so whatever clinical trials you do, they should fall within the, they should have ethical clearance. And then there's something called as animal cloning. These days, we also hear about designer babies. I don't know if it's fact or fiction, but some people also want to have children, who are very clever, maybe beautiful, so on and so forth. So a lot of advancement in research is there, but then, these ethical issues is something that one has to, think about before, actually proceeding further, right? And then there are certain aspects in formulation of a research problem. Okay? And what are these aspects? One is a theoretical aspect and its practical relevance. And of course, the other one is a different issue. And let's talk first about the theoretical potential and practical relevance. So, while formulating a research problem, one has to keep in mind that uh, whether the problem is of does it have a theoretical potential, or does it have any practical relevance. A research problem that we select should be selected such that it has a potential to advance our existing theoretical knowledge. If it does not do so, at least it should have certain practical relevance. Uh, Again, coming back to on the theoretical front, there can be two situations. On the theoretical front, um, uh, like for example, you collect some data from your research project, and that data should be able, I mean, you should be able to link that data to a theoretical structure uh, that is already existing. That is, it should support the existing theory. If it does not support the existing theory, it should be able to refine the existing theory. Or sometimes, you can come up with a new theory altogether from the data that you have collected. Okay, so this theoretical potential is something that is very important in framing a research problem. If it's not having any theoretical relevance, as I said, at least it should have practical relevance. That is, it should have a certain application to the current issues, and it should be able to solve certain current issues in the nation and in the entire world. Therefore, it is of utmost importance to choose a research problem that is, that is helping the researcher to make a contribution to theoretical advances as well as practical advances. Actually, preferably one should be able to do both. For example, in my own research lab, what we do is we work a lot on, I'll just see how we are doing on time. We work a lot on genome analysis. So basically, now we have lots of complete genomes, say from human genome till Escherichia coli, bacteria. In fact, the virus of SARS coronavirus 2, the genome of that is also sequenced. So once you have the genome information available, then it is possible to find out what is the proteome information, that is the corresponding protein sequence information can also be derived. So from the protein sequence information, it is possible to find out what is the likely structure the protein has. And once you have a protein structure that you have derived from the sequence, the primary sequence, that is, you're going from the primary uh, information to the tertiary information directly. And from the structure of a protein, it is possible to find out what is the likely function that the protein has. Okay, so going from sequence to structure to function is a theoretical problem. Okay, so we are making theoretical predictions as to what is the likely function of a protein. So now I would want to find out the practical relevance of it. So what I do is so the first pipeline is sequence to structure to function is a theoretical pipeline. So my problem actually has theoretical potential. And then later on, what I do is I go to the laboratory, I clone this particular gene in under experimental conditions. That is, whatever is in a computer as a sequence is what I make it's like synthesis of something. Okay, I make the protein product using methods in molecular biology, protein biochemistry, and then a protein that is properly folded. From the structure, I proposed a function, right? So now I do all these experiments using enzyme kinetics to find out is my theory right or wrong. I have proposed, say, 5 different functions to the protein based upon the structure. So now I have done the experiments for all the 5 and tell whether my theory is right or wrong. Okay? So as I said, the theory and the experiment should go hand in hand as far as possible. As far as possible. And the next aspect is you can formulate the research problems based on the deductive approach as well as the inductive approaches. So this is one way to distinguish the approaches to framing a research problem. So let's see the first for the deductive approaches. The deductive approach of viewing a problem formulation uh, is basically to tell. I mean, basically, you develop a set of hypotheses to start with, which will be tested based on your inquiry. That is your research. Okay. For this purpose, it insists on having a research design first, and then you have a representative sample, and then you have ideas which are or variables which are dependent as well as independent, and then you also have a standard instrument that you would like to work on. And this is what happens mainly in natural sciences. Okay, without knowing this terminology of deductive science or deductive approach to framing a research problem, this is what most of the scientists do day in and day out, or this is how the research problems are solved. That is, you have a research design to start with, you have a representative sample, and then you have certain dependent variables, independent variables, and all these you're trying to use an instrument to prove your hypothesis. Okay? And the inductive approach is uh, uh, basically an area where you go to the field with an open mind. There are no prior assumptions, and whatever happens is actually happening ab initio in the field. That is, you have to develop, focus, sharpen your investigations depending on what actually happens in the field. Okay, that is you're not making any assumptions to start with. Whatever is the outcome of, say, plan A, I mean, or step A, you based on that result, you decide which way to go for the next step. Okay, so it's like an inductive effect, if you can recall your high school chemistry. So one thing will lead on to the other. It's like a chain reaction. So this is the inductive approach to science. This happens most often to social scientists. Okay, I wouldn't say that this is a routine thing in natural sciences, but this is a routine thing, I guess, in social sciences. But the deductive approach is what happens in natural sciences, day-to-day work. And I just wrote here at this stage something about statement of problem. What I believe is most of the students who apply for for a PhD position abroad. I do not know how many of you are PhD aspirants, but most of the PhD students, most of the MScs, have this great urge to do a PhD abroad, and foreign universities require something called as a statement of problem. So, and they usually ask the in MSc they also do a project. So therefore they write a statement. They write a statement of problem, and then they ask us to correct it, which is nice. We are happy to do it. But then I always tell them what should be the components of a statement of a problem. And because we are talking about synopsis, research proposal, I thought a statement of problem is also very appropriate in this discussion here. So a statement of problem basically defines your research problem, and in a good statement of statement of purpose of statement of problem, one should be able to tell exactly what is to be determined, what is the research question, and one must restrict to the scope of the study of specific problem and not beat around the bush. And and one is required to describe the background of the study, why they have chosen that, the theoretical basis for choosing that problem, and what assumptions were made, what are the underlying assumptions that were made while this research problem is chosen. And if there are any specific issues, okay, be concrete about them, be specific. If there are any workable questions, also raise them. And all the questions that are related to the problem must be stated. And it should not be too broad, as I said, but it should have enough details, and one should be able to narrow down vertically downwards, such that even if somebody who doesn't have any prior knowledge in that subject, okay, they should be able to understand from the statement of problem what the student wants to work on. So basically, it's the overall plan of a research problem, and it should be written in a logical manner such that it makes sense, and you should write in such a manner that it is clearly understood by all. Okay, so so once you have this part done, okay, so if you are able to write a statement of problem, and if you ask your friend in history, supposing say you're doing science, if you're doing research in chemistry, and then if you write a statement of problem and give it to your friend in history and say, read this and say, does it make sense to you? If it makes sense to them, I think your purpose is served. Okay? So with this, I conclude the first aspect, which is the research problem. And now we'll go to the next aspect of my topic, which is the hypothesis. So what is the hypothesis here? The hypothesis is something, I think in my first slide, I told you research problem. In that, after the literature review comes hypothesis, if you can recollect that. So hypothesis is defined as a tentative proposition. It is basically a solution to the problem, and it is an explanation of certain observations. And after you select a research problem, the formulation of the hypothesis is the next important thing. And in fact, logically also, if you see my first slide, this comes as the second step to the research problem. But let me tell you that not all studies will have hypotheses. Okay, this is also mentioned in quite a few books, which you might read later. Sometimes the research problem or the research study is only exploratory. It's only designed based on certain exploratory research. We have also seen what is exploratory research yesterday. So if it is based on that, then there is no hypothesis. For exploratory research, there is no formal hypothesis. So there are certain situations where there is no hypothesis, but at the same time, there can be a single study, and the single study can have one or more hypotheses. So the contrary is also true. So yeah, so in a hypothesis, the researcher attempts to explain the phenomenon that they would like to study, and the explanation that they would like to give, and also tell all the variables that they plan to use in the study. So basically, these are all the predictions. Hypothesis is basically a prediction that one wants to, say whether it is right or wrong by gathering information, by doing the experiment, by analyzing the data. So it's basically the question that you're asking becomes the hypothesis. So the formulation of hypotheses, okay, here you are asking certain questions, and the questions that the researcher asks, okay, is usually framed as hypothesis or the question to be tested, and this is the basis for the evidence that you would like to collect. So the formulation of hypothesis is typically determined with the help of the implications of related research. Okay, so you must have read certain papers to start with from your in your earlier days of PhD, and from that reading of literature, you will have certain inferences, and then you will have a deductive logic. This deductive logic also, I'll come back to that later. And then you'll have a deductive logic, and you will think that if from this problem, if this is the answer, if I frame a similar problem, I will hope to find a similar solution. Okay, so this is called as deductive logic, and one can actually frame hypothesis based on such deductive logic. So what is the importance of hypothesis? The importance of hypothesis is huge. Okay, and in fact, the hypothesis is actually used as a pivot, not used as a pivot. It's actually the pivot about which the entire research problem or research investigation revolves, and this actually gives the investigator a definitive target, and so that many times what happens is we go haywire in our research investigations. We are not able to focus on a particular problem or the particular problem. I mean, one thing can lead on to the other, so you lose track of your research problem. So if you have the hypothesis in hand or in mind, written down somewhere, then it will not allow you to go in any direction. It stops you from directionless research. So the hypothesis provides a direction to the research uh, problem or research journey, I would say, not problem, to the research journey. And also now what happens is the literature is so much that one paper will lead on to the other, and we'll forget why we started off reading these papers, because the first aim itself is lost. Okay. And this during literature search, come across lots of papers. So irrelevant literature collection, reading them, wasting our time, all that will be stopped or prevented by having the hypothesis is mind, by framing the hypothesis or the problem. What problem you would want to crack? That's the crux of the matter here. So yeah, it tells the researcher what is relevant, what is irrelevant, and it sensitizes the investigator to certain aspects of situations, and therefore one is able to pinpoint and say that this is what I would like to understand and nothing else. Therefore, we will not go astray. It is a guide to allow us to think in a particular direction or in the process of our discovery. The hypothesis will let us focus in our research. As I said, without hypothesis, the research work will be mostly random or aimless. Okay? Or it's like telling yourself all the time that this is a problem I would like to work on, and not deviate from that. And it also prevents us from doing blind research. The blind research also will lead sometimes to good answers. Okay, but I'm telling you the advantage of a hypothesis here. So it will prevent us from doing the blind research, and it will also discriminate us from gathering a lot of unnecessary data, because in the process of gathering data, we are doing certain experiments, we are wasting a lot of time. And basically it's telling us what our goals are, what our specific goals are, and it will not allow us to deviate. Like it will allow you to be comprehensive, at the same time it will allow you to penetrate deeper inside, and it will allow the researcher to have clarity in the problem as well as the data. So it allows you to work within a certain framework. Okay, by not wandering away, what you're trying to do is you're trying to work within a certain framework. So that again is as again kept your research is being kept, you're keeping a watch on the research by having the hypothesis in hand. And again, the important aspect that you have is the hypothesis should be testable. Again, if you go back to the very first slide, at one stage I said that from the analysis that you have done, you go back and test your hypothesis. Okay, if your hypothesis is wrong at that stage, maybe you'll have a different way of interpreting your data. That's perfectly fine, but then one has to be smart enough for that. But then the hypothesis that you propose should be tested. Therefore, basically, hypothesis is an educated guess, because you have read papers, and you have done deductive research and said that because this paper said this is the hypothesis. If I have a similar model, maybe the hypothesis will be same. Okay, so basically, hypothesis is an educated guess, regarding the expected outcome of your experiment. So a good hypothesis, if it's framed properly, it should be able to test the, it should able to withstand the test of time whenever, after 2 years or 3 years, whatever, time you have taken to complete your research. And sometimes, based upon, as I said, the experimental outcome, we should have a free mind or open mind to alter the hypothesis. Okay. It's not like saying, my rabbit only has 3 legs. You should be willing to, rephrase your hypothesis. And this happens very frequently. Okay. For example, again, in the organic lab, okay, I am expected to develop a hypothesis and then do certain experiments. Okay. And at a later stage, when I go back and test my hypothesis, apply this to my hypothesis, I might have get an expected answer, or I might even get an unexpected answer. As I said, I should be having open mind to do this. So that is testing the hypothesis. That's again an important part of the hypothesis. And the hypothesis should be very brief and clear. As I said, there's no beating around the bush. You should only have 2 to 3 different questions that one would like to ask and answer them. You can rephrase it in many different sentences in your mind. But if you ask me what is the objective of your work, you should say these 3 are my objectives, or these 5 are my objectives. Okay, nothing more than that. So hypothesis should be stated very clearly. I'll also ask the students later on to tell me what is the difference between the hypothesis and an objective. Okay, the distinction is very clear. I'm just saying that because I'd use the word objective instead of hypothesis. The objectives of a problem are different from that of the hypothesis. Right. So the objectives should be very clearly stated, and they should be very brief, and it should be very easy to test them. And as I said, if you have any unexpected answer, one should be able to, go back and rephrase the hypothesis. And there are certain characteristics of good hypothesis. These are very brief, and as we were saying that there is something called as a fact and theory. Okay, uh, or theory and experience. Okay, so both there should be a consistency between the facts and theories. That is a part of a good hypothesis. As I said, if you don't find correlation, go back and correct yourself. That's absolutely fine. In fact, that is how new research evolves, right? If whatever hypothesis you started off with, if your hypothesis is always right, okay, then no new science is happening. Only if you are able to find unexpected answers, then you're better off. Okay? And many a times you require courage to say that you're getting new result. Uh, I'll just finish this and come back to that example again. And yeah, as I said, even if one gets an unexpected answer, one should be able to explain that. For example, this routinely happens in organic chemistry. You put A and B together and expect C only to form all this. But what happens is you get C, yes, but then you also get B as a product. Okay? So because then you'll scratch your head and think that A and B previously gave C, and now I'm getting D, so I will erase all the peaks from NMR so that I'm not able to show, I don't have to show D to my teacher. But D has come because of certain natural phenomenon. Okay, maybe you have altered conditions, maybe you have changed the reactants, maybe you have done the refluxing for a long time or shorter time, therefore your product C is getting converted to D, therefore there's an equilibrium between C and D. Okay, so on and so forth. So if you want to simply say that because somebody else showed A and B giving rise to C, I will also show the same thing, then you are fudging data, yes, but at the same time you are not trying to explain why D has come. Okay, so yeah, so there has to be a consistency between fact and theory, but then when such consistency is, when it is not there, go back and make a new theory again. And as I said, in chemistry we can do certain calculations at a very high level, using certain ab initio calculations. This is what Professor Harjinder, who was a speaker earlier, he does. So you can go back and do such calculations at minute scale and at minute level, and find out such calculations actually will tell you the why the unexpected answers came. So if there is no consistency between theory and experiment, even better, you will have a new result that will come up with a different subject altogether. And the important thing is that you should be able to explain your data in very simple terms, nothing complicated. I think most of us should be able to communicate our findings to a common man or to a layman. Okay, if you can tell your research and the purpose to your grandmother or to your as I said, to your friend, not even friend in history is not a good example. They read newspapers. But if you're able to tell an elderly person who doesn't have any contact with day-to-day life with science, if you can convince them that what you're doing is important, then that's exciting. And the problem, as I said, should be stated in simplest possible terms, depending upon the complexity of the concepts involved in the research problem. No matter how hi-fi your problem is, a very in simple terms one should be able to explain. I often felt it is difficult, but somehow the journalists have a very happy, are very good at it. Okay, what is very complicated in a research paper in a journal becomes very easy for a journalist to write in a newspaper article. And this we have said earlier. Your hypothesis should be testable using both empirical as well as the conditions. Right. So you should have a testable hypothesis to say whether whatever guess you started off with, is it valid or not. Okay, that is what is the meaning of testing your hypothesis. Okay? And then this slide shows you, this is the last slide. This tells you what are the necessary conditions that are conducive for the formulation of hypothesis. Okay? There are many steps to this. I've just taken the ones that I felt were important. Yeah. So what basically it means is that first is the how do I start here? I'll just go as per the way it is given here. First is the inductive hypothesis. In the case of inductive hypothesis, what one tries to did I skip a slide? Just hold on. I think when I was editing, I removed a slide. Never mind. Okay. Yeah. So when you want, never mind. Okay. I think I'll try to cover that in the next if required. So basically, when you want to deduce the hypothesis inductively, after making certain observations of behavior, so you have a certain research project from the previous experience, and then you have made all these observations based on the previous experience, and you may deduce a hypothesis inductively after making observations of behavior, noticing trends, and probable relationships between, as I said, A and B components. One will be able to make a inductive hypothesis. That's one way of formulation of hypothesis. So if it has happened in some situation, I'm trying to see if it can happen in another situation also. And the other thing is limiting the problem. So what is the limiting the problem here basically means that you have certain basic understanding of the literature that you have come across from a previous experience, but on a different problem altogether. And the researcher here must have the ability to comprehend the available evidence, okay, in support or against the expected relationships or the unexpected relationships. Therefore, whatever hypothesis you have formulated, okay, that can be limited in a yes manner or in a no manner. That is, you can agree with your formal hypothesis, or you may not agree with your formal hypothesis. Or the other way of looking at it is called as deductive hypothesis. And this deductive hypothesis basically means that you have formulated a study based on a particular theory in the area of your interest, and then you have now deduced the hypothesis from this theory through logic. The logic always plays an important role. I did not use the word logic. As I said, that is the one that is there in the slide that I've actually missed. Never mind. Okay. So this can come from restructuring, one's own experiences in research. So experienced people can actually do this, and you require a lot of creativity to make a deductive hypothesis. That is, you have certain experiences to start with, and now you are trying to uh, now you are trying to as I wouldn't say contradict. Now you are trying to support or not support your hypothesis. Uh, but as I said, one needs to have enough experience uh, to to have a deductive hypothesis. And I would say that one will require a lot of adventure. It's not just one should be courageous. Okay, as I said, if I want to report an unexpected byproduct, okay, I need to have a lot of courage, because first of all, none of the scientists will believe it, because they have only seen so far that A plus B are giving me C and nothing beyond that. And sometimes the hypothesis can also be formulated based on analogies or conversations. So analogies means again drawing one to the other. Okay, based on something you can come up with a new proposition. So analogies also lead a researcher to clues that may provide useful information to formulate a hypothesis or find problems to solutions. For example, there is a new problem, and this new problem resembles the one that was faced by somebody else earlier, and therefore one will go back and see what kind of factors were studied then on a particular problem. Supposing, say, there is a field, there is an agricultural field, and it has come up with some pest. So instead of starting your research all over again, you don't have to go through all the steps, but then you can say that during that time, because this pest had infected the plant, okay, say tobacco. So I would like to go back and see their work and find out what is it that they have done to overcome the situation. So you're drawing parallels between the previous research and the current research, and uh, draw a relationship between the old situation to the new situation. And again, though you're trying to draw an analogy, such analogies may not be valid, because see, maybe that time the pest had come in a different season. Maybe the soil was different then. Okay, maybe that place has a different soil and this place has a different soil. So whatever that pest control was done, it's not valid because of many situations. Okay, so though we draw a hypothesis also from these angles, okay, it may not be valid all the time, as I said, because of the different conditions that are prevailing. For example, if you read newspapers these days, people always talk about COVID drugs. Okay, and they say that first they said there is no COVID drug, then of course it's true, and then they said perhaps chloroquine will work. Then they said that perhaps hydroxychloroquine works. Then they said maybe remdesivir is working. Then they said some favipiravir is working. So how do people come up with such uh, names of drug molecules? Okay, for example, remdesivir was discovered earlier for this Ebola virus. Okay, there is a protein called as RNA-dependent RNA polymerase, and remdesivir was a drug to that, was an inhibitor to that. But then Ebola virus died very quickly. It was not problematic, but then that drug did not take off. But then because the RNA-dependent RNA polymerase in Ebola virus and SARS coronavirus 2 are more or less similar, then people thought that in the absence of any drug, it is okay to try remdesivir because the target proteins are similar. Likewise, there are certain proteases in SARS coronavirus 2, and there are certain HIV drugs, such as this what are the names? I'm not able to recall straight away. But anyway, there are many drugs for HIV protease, um, and those drugs were actually being tested for coronavirus also, because coronavirus also has a similar protease similar to that of the HIV protease. So now what people have done is, based upon their previous experience of a problem, okay, which is the hypothesis, they have drawn analogy and they have said that is it possible to try these? But as I said, these are different viruses, but in the absence of no drug, some guess drug was okay. So that's how these drugs are being administered. And there are many forms of hypotheses. See, actually, for somebody who has not studied, these subjects as as a formal course curriculum, also do these things. Okay, all of us do inductive hypothesis. Most of us do, you know, analogous hypotheses. These are all framed every now and then. But then it's just that we don't know that it's called as an analogous hypothesis, or it's not, or we didn't know that it's called as a inductive hypothesis. Anyway, so now going to the forms of hypothesis, there are so basically there are, what is a form of a hypothesis? How do you, so basically this tells you that uh, yeah. So basically there is a question in the hypothesis. Okay, so what is it? So it's called as a question form. I think I'm not showing you the right version of the thing. Anyway, I'll show you the last part first here. So the question form of the hypothesis basically says that um, a hypothesis is stated as a question. It is the simplest level of empirical observations, and you want to know, is it possible to synthesize compound C using this particular procedure? That is the hypothesis or question that you have actually posed. Okay, so this is the simplest form of the hypothesis that I can think of. Therefore, I'm talking about it first. But I would say that this fails to fit most of the definitions of hypothesis. So if you go back to books, they don't put the question form anywhere. They only say that there are three forms of hypothesis. They say declarative form, directional form, null form are the three forms of hypothesis. But I believe that the question form of the hypothesis is the most important one, because this is what comes to our mind first, isn't it? Before even you think of anything, you first ask a question. So I believe that the question form of the uh, of the form of hypothesis is the most important one. Uh, these are the cases where simple investigation can be done, and which, when adequately implemented, you'll be able to answer whether A plus B is giving rise to C or not. So this is the question form of a hypothesis. And the other form of hypothesis is a declarative statement. So a hypothesis is developed as a declarative statement. Uh, it provides an anticipated relationship or difference between variables. So you anticipate what the outcome of your research problem would be. Uh, Such a hypothesis developer normally has come up with a hypothesis because they have examined the existing evidence, which led him or her to believe that you know uh, a certain difference may be anticipated as an additional difference, because you already have a slight doubt in mind. So basically you have certain independent variables, and then one would want to play with certain independent variables and come up with a with the uh, with the with a declarative form of hypothesis, and you would want to prove whether it is right or wrong. The other kind of hypothesis is called as the directional hypothesis. And in the case of directional, I'm not able to think of any um, examples straight away, because as I said, these are actually practiced in the laboratory, because like as I said, uh, if you are doing always A plus B giving rise to C, you're not doing any new research, right? So in the process of doing A plus B giving rise to C, you will change many parameters, reaction conditions. You will change the substituents on A, you will change the substituents on B, and then you're trying to see what is the research outcome. So during these, as I said, you go back to your theory uh, of A plus B reacting together, and then you will already have certain intuition in your mind whether it is going to go in the right direction or whether you will get a different answer altogether. Okay, so all these things will come in the framing of hypothesis also. You just directly don't go based upon you have a lot of intuition also, And this intuition is coming not because of some gifted power. This intuition is coming because of reading literature. Therefore, reading literature is most important, and attending seminars. Okay, in the literature, what happens is you only see the positive result of a particular experiment. Nobody tells you an experiment that has failed. But if you attend seminars, then they will tell you that a particular experiment had failed, and they'll also try to explain why it had failed. So then you'll be able to frame your hypothesis very nicely. Anyway, coming back to the next one, a directional hypothesis. A directional hypothesis predicts an unexpected direction or a relationship because you are able to tell the association between two or more variables in a reaction. And in this type of hypothesis, the researcher appears to be more certain about the anticipated evidence, because they are already providing a direction to their result. And also what happens is that if this hypothesis is acceptable, then I would say that it is actually less safe, because as I said, you're not doing anything challenging. You're doing something like a copy paste research. Okay, you know that something has to work, and you're making it work. Okay, and as I said, the examiner, the researcher should be able to examine all the variables such that at least some novelty is brought into the hypothesis. So at least this advancement has to be made. The other is called as a null hypothesis, and in this hypothesis, basically, this hypothesis is stated in a null form. What is a null form? It is nothingness. Okay, in which there is no assertion, there is no relationship, and there is no association made between different variables. And in the case of a null hypothesis, it's as good as not making an assumption. Okay? A null hypothesis, I started off by saying that not all problems need to have a hypothesis. Okay, that's a different category. So by saying that it is a null form of a hypothesis, what I'm trying to say is that you have variables like before, but then you're not trying to make any association between them. You know what kind of answers to expect. This is less than an intuition. You're trying to make a guess of the likely outcome. You do not even have any concrete proof. Okay. In the case of no hypothesis, it is exploratory research. You don't even know where the tunnel will end. Okay? It is as bad as that. In the case of research that starts without any hypothesis. But when I say that null hypothesis can be, again, maybe it is the most vague form of research, where you have variables, but then you're not making any relationships between these variables, and then you let the research evolve, and then you let the research evolve to make to give you an answer, whether and then you can decide whether you have got the right answer or the wrong answer. So these are the 4 forms of hypotheses that one can get. And once you form a hypothesis, this hypothesis has to be tested, and Professor Hargopal will tell you how to test these hypotheses in the future classes. And I thank you all for the patience. I didn't put the references. You can take them same as what I had given you yesterday. Thank you.
Thank you, ma'am.
So shall I stop sharing?
Yes. Thank you, ma'am. Now the questions, the lecture is open for question and answers.
Sure.
Participants, please discuss your issues, problems, take advice from ma'am.
Yeah, as I said, let me again make it very clear that most of us, frame a problem. Most of us do literature search. Most of us, also frame the hypothesis without giving it a term or a terminology. right? I mean, all the steps in the PhD problem, in framing the problem till the entire research journey happens on a day-to-day basis without actually giving it a terminology. But when you go back and hear such lectures, then perhaps one will think that, oh, is this is a drug for complete deductive hypothesis. It's something like that.
Somebody is trying to say something. Hello, you could hear voice but couldn't hear properly. Pose your questions in the chat window at least.
Shall I see the chat? The sound is not clear, not audible. I'm sorry about that, but I hope it was okay. Could you, Rajesh De Purulia, was the sound audible, sir? Sound was okay?
We can hear you. We can hear you, but that
2 o'clock.
question, some
2 o'clock. Thank you. Thank you, Mahesh. So
hello. Yes, ma'am. Yes.
No, I thought if nobody is asking, I thought I can ask this. If there is I do not know how many of these are students, but I just wanted to ask them how many of them have framed their own research problem, or what is the source of research problem to them is my question to them. In fact, I wanted to put that research poll, but I did not know how to do it.
Which what is it?
The question here is how many of the PhD students have framed their own research problem? That was the question.
There are some comments from Mr. Mahesh.
Yes, sir. I've opened
a very interesting session, ma'am. From Arun Kumar.
Thank you, sir. I'm seeing the chat box. I thought they will put some questions in the chat box, therefore I've also opened that.
Yeah. So, ma'am, can I ask you a question if
sure, sir.
Others aren't asking? Yeah. Because what I have realized that from the times, say, I was a research scholar somewhere in 88, 89, when I was approaching, the general trend was we had time to define a problem, think about it for a year or two. I broadly knew the area I want to work in, but I was groping for a problem and do it.
Yes.
But nowadays the trend is the research scholars have to give a problem they want to work on for their PhD entrance exam. This is what we expect them to give when they are applying for PhD. We want them to say what they want to do.
Yes.
And secondly, the time has been reduced. Earlier it used to be 5 years and even more. But now within 3 years, people are through with their PhD. And very often to do a thing like that, you have to assign a specific problem and tell them exactly what to do and things get done. So that freedom which was there to explore, look around, decide, which you discussed in your talk too.
Yes.
Is it lacking or is it still there in some institutions?
It's an interesting question, sir. I would say that PhD is a training process, right? I'll see if I
can. Like PhD, it has become.
It's actually a training ground. Okay, even if they are not doing great science, it is okay. I'm just trying to see how to. My videos here. See, even if somebody is not doing great science, I think if it's like learning tools. It's like learning how to frame a problem, and it's like how to address the problem. So I think that is what a PhD is supposed to be. But if students are in a hurry to finish it, they will finish a PhD. But then I think they will. I mean, as you rightly said, there was enough time to explore. There was enough time to make a mistake, and if a problem did not work, it was perfectly fine. After 2 years also, we could go back, do course correction, and start all over again. But students are not willing to take that risk. They want to start from day one only. But I think in the process, what they are losing is they are losing the the comprehensive base of the subject, isn't it? It's like you want to go only for the main course and or dessert, and not having the starters, all the in the 5 course meal. They only want to have the dessert and not have the enjoy the whole course meal. I feel that there is a lacking in the current hurry to finish. Yeah. So I think
That's right.
so what I feel is, sir, this is what happens in chemistry school often. The students are in a hurry to finish. The supervisors are also in a hurry to make them start. That's nothing wrong in that. But then they once they start the lab work, wet lab work, they fail to go back to the textbooks again. They fail to read journals. They're only deep dwelling in their subject and not looking horizontally. That horizontal knowledge, I think, is something that is lacking.
That's right, because it is reduced to become yet another degree which they want to get, and maybe get a job, or if they're already working somewhere, to get promotions and so on. We can't blame the youngsters to that, but that's how the whole attitude has overall changed.
Yes, sir. But I think if the students realize the importance of looking around of having a horizontal breadth of knowledge, it will actually help them, right? I mean, I was telling somewhere that the research supervisor also will look for problems either from PhD or postdoc. Okay, that's one aspect of looking at it. But I think if you want to continue your PhD problem, that is incorrect, because that is your supervisor's problem. If you when you're for your PhD, you should be able to work on a new after your PhD. When you become an independent scientist or teacher, whatever, you should have your own research problem to work on. So if you do not have that breadth of knowledge, then you will fail to frame the question, right? So a student should not be in a hurry and take enough time, even if it's a little bit more, but do a methodical PhD, so that you actually it's an advantageous thing. It's nothing wrong in waiting a little longer but learning everything properly.
That's right. Yes. So thank you, ma'am.
Thank you so much, sir. Thank you for the opportunity given.
Yes, it was a lovely session, very informative and very useful for the people. Thanks a lot.